Hello everyone. This is Anupam Sahu, Associate Professor in Pharmaceutics. Welcome you all in my YouTube channel Pharmajeeaap. Today we'll discuss about solubility of drugs. So first of all, what is solution? Generally in home we used to prepare juice. To prepare juice, first of all we have to take sugar, then we'll add water and mix it to form sugar solution. Here sugar is solute which is taken in less quantity and water is solvent which is taken in more quantity compared to sugar. So we can say when solute is dissolved in solvent, it forms solution. Remember, solute is always taken in less quantity compared to solvent. So this is solute, this is solvent. When we'll mix both solute and solvent, then it forms solutions. In next slide, we'll discuss in detail about solubility. So what is solubility? The ability of a substance, that means solute, to dissolve in a given volume of solvent at certain temperature to form homogeneous solution is called solubility. That means when solute dissolved in solvent at a certain temperature and it forms a homogeneous solution, that means it is called as solubility. So what is solute? Solute is a component which is dissolved in solvent present in less amount in the solution. This is the solute. It is taken in less quantity. Next is solvent, a component in which solute is dissolved present in more amount than solute. Next is solution, a system in which solutes are dissolved in solvent to form homogeneous molecular dispersion, that is called solution. This is solution. When solute is dissolved in solvent, then it forms solutions. So as we know, when solute mixed with solvent or dissolved in solvent, it forms solutions. So in figure 1, solute is dissolved in solvent. Solute is here, the blue color is solute, the dissolved in solvent to form solution. Here the solute particles are evenly or uniformly mixed. In figure 2, solute are uniformly distributed in the solvent to form solution. Types of solutions. First is unsaturated solution. Solution containing dissolved solute in concentration below that necessary for complete saturation. That means we can add further solute in the solution. There is a scope for addition of further solute in that solution. This is called unsaturated solutions. Next is saturated solution. Solution in which the solute in solution is in equilibrium with solid phase. That means no more solute will be dissolved in the solution. This is called saturated solution. Next is supersaturated solution. Solution containing more of the dissolved solute than it would normally contain. Means excess amount of solute dissolved which becomes unstable or may form crystals. This is the supersaturated solutions. If we'll take on an example, for example, maximum 10 gram of sugar can be dissolved in 100 ml water for complete saturation. In this case, it is called saturated solution. Means maximum 10 gram of sugar can be dissolved in 100 ml of water. That is called saturated solution. Means no further sugar we can add in normal conditions. If we'll add 5 gram of sugar in 100 ml of water, means there is a scope for another 5 gram of sugar into the water. In this case, it is called unsaturated solution. And if we'll increase the temperature of the solution, then we can dissolve another 1 or 2 gram of sugar into the 100 ml of water. Means we can add 11 or 12 gram of sugar in water. And beyond that, it forms crystals. It may become unstable. In this case, it is called supersaturated solution. Hope you understand. Solubility expression. The solubility of drug or other substance in a solvent can be expressed as numerous terms via normality, molarity, molality, mole fraction, percent weight, percent volume, percent weight in volume, parts per million. So first is normality. Normality is denoted by capital N. It is defined as number of gram equivalents of solute dissolved in 1 liter of solution. Remember, 1 liter of solution. That means N is equal to number of gram equivalent of solute per liter of solution. Next is molarity. Molarity is the amount of substance in certain volume of solution or moles of solute per liter of solution. It is denoted by capital M. Molarity is also known as molar concentration of a solution. That means M is equal to moles of solute per volume of solution. Next is molality. Molality is denoted by small m. Molality or molar concentration is the number of moles of solute present per kilogram of solvent. Remember, in case of molality, we will consider kilogram of solvent. Here we are taking the weight of solvent in kg. But in case of molarity, we are taking the 1 liter solutions. This is the difference between molality and molarity. In case of molarity, we are taking 1 liter of solution, whereas in case of molality, we are taking kilogram of solvent. So molality means molarity is equal to moles of solute per kilogram of solvent. Next is mole fraction. It is the ratio of number of moles of solute to the total number of moles of solute plus solvent. X solute is equal to moles of solute divided by moles of solute plus moles of solvent. Means we can calculate by moles of solute divided by moles of solute plus moles of solvent. Mole fraction is unitless and X solute plus X solvent is equal to 1. Next is percent weight. It is the mass of solute divided by mass of solution and multiply by 100. Percent weight is equal to mass of solute divided by mass of solution into 100. Next is percent volume. It is the volume of solute divided by volume of solution multiply by 100. Percent volume is the volume of solute divided by volume of solution into 100. In percentage weight, we are taking in weight, whereas in volume, percent volume, we are taking considering it in volume. Percent weight in volume. It is defined as mass of solute divided by volume of solution multiply by 100. Percent weight in volume is equal to mass of solute divided by volume of solution into 100. Next is parts per million, that is ppm. The concentration of component A in solution in ppm is defined as ppm of A is equal to mass of A, that means weight of A, divided by total mass into 10 to the power 6. Classification of solubility. Solubility are of 7 types. First is very soluble. It means 1 part of solute is required to dissolve in less than 1 part of solvent. Means less than 1 part of solvent is required for 1 part of solute. Freely soluble, that means 1 to 10 parts of solvent is required for 1 part of solute. Soluble, 10 to 30 parts of solvent required for 1 part of solute. Sparingly soluble, 30 to 100 parts of solvent required for 1 part of solute. Slightly soluble, that means 100 to 1000 parts of solvent is required for 1 part of solute. Very slightly soluble, that means 1000 to 10,000 parts of solvent required for 1 part of solute. Practically insoluble, that means more than 10,000 parts of solvent required for 1 part of solute. So this is all about classification of solubility. Solubility rules. A solute dissolved in a solvent when it forms favorable interaction with like dissolves like. Solubility rule indicates that ionic or polar solute dissolved in polar solvents, while non-polar solute dissolved in non-polar solvents. Polar solute are not soluble in non-polar solvent, and non-polar solutes are not soluble in polar solvent. Mechanism of solute-solvent interaction. Depending on the nature of the solvent, mechanism of solubility is there, which we will discuss here. So first is polar solvent. For polar solvent, mechanism of solubility are high electric constant, hydrogen bond formation, and dipole interaction. The example is water in ethanol. Next is non-polar solvent. Here mechanism of solubility is weak van der Waals forces. Fats, oils, alkaloidal base plus CCl4 and benzene. Next is semipolar solvent. Here the mechanism of solubility is induce certain degree of polarity. Acetone increase solubility of ether in water. This is the best example for semipolar solvents. Mechanism of solute-solvent interaction. The mechanism basically involves in 3 steps. First is detachment of solute from bulk form. Means here the solute is detached from the bulk to form a separate entity. Next is formation of vacant site in the solvent. Here this is the solvent, this is the vacant site. Okay. Next is the solute or drug molecule that is inserted into this cavity. This is the drug in solvent. This is the drug molecule that is inserted into this vacant space. So this is the solute, that is the separate entity that is detached from the bulk, and this solute comes in contact with this vacant space and it was fixed here. So this is all about mechanism of solute-solvent interaction. Thank you. Thank you so much for watching this video. If you like my videos, then like, share and subscribe. Thank you.